These are skyscrapers and they seem almost impossible, yet they stand firm against wind, earthquakes and time itself. So how do these engineering marvels work? Why don't they fall? Let's unravel the bizarre science and brilliant engineering behind skyscrapers. First, let's talk about the foundation. A skyscraper's strength begins underground. You see, to build up, engineers must first dig down. Depending on the soil, this can mean driving deep piles into the earth or even anchoring the structure to bedrock. For instance, the Burj Khalifa in Dubai has foundations that extend over 50 meters into the ground. Without this solid base, the entire structure could tip over like a pencil on a slippery table. But here's the twist. Foundations alone aren't enough. These towering giants also owe their stability to something counter-initiative: flexibility. Yes, skyscrapers are designed to sway. Wind is one of the biggest challenges for skyscrapers. At heights of over 1,000 feet, wind speeds can reach hurricane levels, exerting immense force. If a building were too rigid, it would snap. Instead, engineers design skyscrapers to bend, but just slightly. Take the Taipei 101 in Taiwan. Inside it has a 730-ton tuned damper, which is a massive steel ball suspended by cables. When the building sways, this damper moves in the opposite direction, counteracting the motion. It's like a giant pendulum keeping the building steady. Now, what about earthquakes? Some skyscrapers are built in regions where the ground itself is a moving thread. Engineers here use cutting-edge techniques like base isolators, which are devices that allow the building to move independently of the shaking ground. Skyscrapers also rely on their steel skeletons, which are those intricate frameworks of beams and girders. The real magic of skyscrapers is in the materials. Concrete, for example, has come a very long way. High-strength concrete used today can support thousands of pounds per square inch, and when combined with steel reinforcement, it's practically indestructible. Yet, building up isn't just about strength, it's also about weight. Skyscrapers can't afford to be heavy. That's why engineers use lightweight materials like aluminum, glass, and even composites. This reduces the load while maintaining structural integrity. Let's not forget about aerodynamics. The Burj Khalifa, for instance, has a unique step design to confuse the wind. This prevents vortex shedding, a phenomenon where wind creates powerful whirlpools around a structure. Without these aerodynamic tweaks, the Burj Khalifa might have been a giant wind sail. Modern skyscrapers are also getting smarter. Sensors are now embedded within buildings to monitor stress, temperature, and vibrations in real time. These systems can even predict failures before they happen, making skyscrapers safer than ever.